Welcome to the APES Math Review. Okay, so some basics in case you're not knowing or forgot how all this stuff works. Scientific notation. Let's start with that. Let's find a decent color to work with. Let's do blue. Okay, so scientific notation means you're always going to have a number, then a decimal point, and then all the other numbers. So you will always only have one number to the left of the decimal point. That's scientific notation. So the key here is however many times you have to move the decimal point to get to that one number to the left, then you add this 10 to the power of something, 10 to the x. So for example, before we get over there, let's say I have, I don't know, 256. Well, the number 256, there's an implied decimal point right here. So according to our scientific notation rule, we want to move this decimal so it's right here. So we're going to write 256 2 times, oh sorry, that's not true. I forgot the other numbers. You can't do that. Okay, 2.56 times 10 to the however many places I had to move that decimal. So I had to move it one place, two place. So this would be 10 to the 2. And so all this 2 means is to undo this from scientific notation. If I move this 1, 2, then I have 256. What? That's it. That's all this is. So it's just practice, practice, practice. Now the reason we do scientific notation is because when numbers get really, really big, we usually don't count our zeros really well, or we get lost in all of those zeros. And so it's easier to keep track using the scientific notation. So 1 billion is 1, that's a million, and a billion is 12 zeros. So instead of writing it that way, we would do 1.0, understood, times 10 to the however many times we had to move this understood decimal over here. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 1 times 10 to the 9. Box your answer. All right, let's look at this one, 23,000. 23,000 is how we would normally write it. Using scientific notation, 2.3 times 10 to the, how many times did we have to move this decimal over? 1, 2, 3, 4. So it will be 10 to the 4. Box your answer. You have to box your answer or you won't get credit on the AP exam because they don't know what number you want to be your final answer. Okay, number 3, 70 trillion. So a billion is 9 zeros, trillion is 12 zeros. So 7.0 times 10 to the 12 zeros, but then there's this 13th zero right there. So we're going to go 10 to the 13. That's a point. That's ugly. Pretend that says 7.0 times 10 to the 13. Why? Because over here, trillion, that would be 70 and then 12 zeros. 4, 5, 6, 7, 8, 9, 10, 11, 12. And so again, if I bring this decimal point all the way to here, I moved it 13 times over. That's all that means. Okay, let's do an easy guy. 300. So that's 3 times 10 to the 1, 2. That's it. Okay, now going the other way for really, really, really small numbers. Sometimes we have tiny numbers like microbiology stuff. We're in like these really precise measurements, same thing though, we still want the first number to the right of, or sorry, to the left of the decimal. So we're going to move this guy to here. So we're going to write 2.5 times 10 to the, and when we move the other way, it's negative because we're moving that way. So if we're getting a bigger number, it's a positive 10 to the power. If it's a small number, it's negative. So we moved it 1, 2, 3, 4 times, so it's 10 to the negative 4. Which means I know I have to move this decimal point this way 4 times. Okay, 7, 3, 10, 7.31 times 10 to that. And you don't have to do all these extra zeros either. When you're like doing these numbers, you can just stop after it's like actual numbers. So our decimal point's here. We need to move it all the way to here. And that's 1, 2, 3, 4, 5, 6. So 10 to the 6. Boop. Now you know scientific notation. So easy. Well, let's go the other way. Okay, 500 billion. Oh, we're doing calculations. Oh, sorry, math. Okay. There's some fun stuff in scientific notation, but you don't have to know it now because you are allowed to use calculators. So you don't have to do mental math if you don't want to. But let's write this number out. 500 billion. Well, I don't want to write 5 and then 9, 10, 11 zeros. I don't want to do that. So I'm going to write it in scientific notation. 5 times 10 to the, a billion is 12. Sorry, 11. Maybe I better do it. I already forgot what's going on. Oh, that's a trillion. So, okay, wait. This would be a billion. So 500, 1, 2, 3, that's 500,000. That's 500 million. Here's 500 billion. So 3, 6, 9, 10, 11. So that's 5 times 10 to 11. I just counted how many zeros to put the decimal there. It was 11. So 5 times 10 to 11 is this 500 billion times, I'm old, so I do this. Some of you guys do a little dot for times, but I feel like it gets confused with our decimal points a lot in science. So I'm going to stick with that. 35,000. 3.5 times 10 to the, so let's look over here for a second. 35,000. 1, 2, 3, 4. 10 to the 4. So we're just multiplying these two numbers. Okay, so I don't know what calculator you've got going on, but if you have this guy, the Texas Instrument one, you're just going to type in 5, and then instead of, you don't type in times. We're not multiplying that number. So this times 10 to the 11 thing, you have to put in on your calculator. I'm going to write the numbers you would put in your calculator. You're going to put in the 5, then you're going to hit the button that says second function, which is here, this guy. And then you're going to put this button right here. It says x to the minus 1, but since we did second function, there's a little e there, and that's the exponent to do this scientific notation thing. So this is x to the minus 1. Ugh, that's terrible. Let me do that again. X to the minus 1, but it's really the E for exponent button, and then you would put the number 11. So these are the buttons you would physically push on the calculator to make this go into your calculator. Then you would do times. Let me get rid of this stuff over here. So then you're going to multiply it by the other scientific notation number, and that was this one. So you're going to put in your calculator the button 3, the decimal point button, the 5 button, then the second function button again, because we want to do that 10 to the power of, that x to the minus 1, which is really the EE button, and then 4. So if you put all these numbers in here in that order up there, you're going to get an answer of 1.75 times 10 to the 16. Shoot, why is my pen being crooked? 1.75 times 10 to the 16. Okay, so now try number 8. I'm not going to put all those buttons down. So 6,000 divided by 300 billion. I'm going to make my pen a little skinnier so we can fit all this on here. Also, I'm going to take this away. I don't have enough space. So sorry. Okay. 6,000 is 6 times 10 to the 3 divided by 300 billion. So 3 times, now remember how many zeros billion is? 9, but then we have 2 extra zeros here, so it's going to be 11, 10 to the 11. Same thing. So I'm going to put in my 6, my second function EE button 3, the divided by sign, the number 3, second function EE 11, and if I do that, I should get 2 times 10 to the negative 8. So remember that is 0.1234567 That's what that number is. So scientific notation is just to make this way more convenient to write, less things to write. Okay, so same thing. So this is the exact same deal. 3.4 times 10 to the negative 2, which is really like 0.034, divided by 1.7 times 10 to the negative 5th, so that's like 0.000015 or 17. If you put that in your calculator, you're going to get 2 times 10 to the 3. Okay? All right, so then number 10. Same thing, we'll just keep practicing it. So 1 times 10 to the 5th divided by 2 times 10 to the 3. So that's going to give you 5 times 10. Oh, sorry, to the, what is that going to give me? I didn't do that one out. Beforehand. Let me do it really fast. 1 exponent 5 divided by 2 exponent 3 is 50. So you can just write 50 how you want, or that's 5 times 10 to the 2, which is kind of weird. But you could, it's totally okay if it's like a regular old number like that, you can write 50. Okay, 11. Let's move this up a little bit. Okay, so number 11, same thing. If you put that in your calculator, you should get 7 times 10 to the negative 7. Fun fact, I don't know if you learned this in math class or not. When you're multiplying exponents, you can take this number times that number, and then you can just add the exponents. So negative 2 plus negative 5, negative 7. If you do 3.5 times 2, that's 7. So you can do it in your head if that's like your thing you like to do. And if you're doing dividing, you just divide this. So if you notice, twice of 17 is 3.4. So 3.4 divided by 17, or 1.7, is 2. And negative 2 minus a minus 5 is a positive 3. So you could do it in your head if you wanted to like check yourself a little bit. Okay, this last one, 1.11 times 6. Let's do that one. So it's going to be 6.66 times 10 to the 4. And that is how we do scientific notation. It is faster if you practice it and you're used to it. This is a time saver on the multiple choice test and the FRQ. Instead of writing all those numbers out, It is meant to make it go faster for you so you have more time to answer the other questions. So if this is like a time waster for you, practice this. I have tons of scientific notation stuff, but you should be good at it. It's expected you know how to do this by the time you get to me. You should have done it in chemistry, and you should have done it in physics if you had physics. So if you need more practice, definitely get faster at this because it will end up being easy for you, free points, and buy you more time for the rest of the questions where you need to think more. Okay, let's go to the next one. So this is the metric system. Also something you're supposed to know already, but I'm pretty surprised on how many people don't. So if we did it in physics a little, you should have done it in chemistry a little bit, and you should have done it like a long time ago in the other classes of science. But if you didn't, I'll give you my little, sorry, the dog's going crazy. I'll give you my little spiel on how this works. So looking over here, let me move this over a little bit for a second. Okay, this is like how the metric system's laid out. You do not have to memorize this, but I think it might make sense for you to like understand it. So our normal units that we use, like grams, meters, liters, watts, those are all like the base unit. And so we give that a base unit of 1, or 10 to the 0 is the same as 1. So here it is right here. It's worth 1. As we get bigger measurements, like we get to kilograms and all those other things, megagrams, giga, everything goes up by a multiple of 10. So if we're going up this way, we're just moving. Notice it's 10. So 10, let's just say grams. 10 grams is called a decagram. 10 decagrams is a hectogram. 10 hectograms is a kilogram. And so from a gram to a kilogram, there's 1,000 grams in a kilogram. So everything just goes up, 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 up by 10. And each thing has its cool little own prefix. It is expected that you know this kilo down to milli. It's expected you know these prefixes. And with things the way they are, you should probably know what a mega is, like a megabyte. That could be, that's our computer like memory size, but it's also a megawatt and a gigawatt when we get to energy, which we are. So again, it's just multiples of 10 every time we go up. But notice now we're jumping by threes. So we don't do 10 to the 4, 10 to the 5. We just go from a kilo to a mega. So this is 1,000 jump. It's like 3 times 10s going up. So notice we're at 10 to the third. Then we go to 10 to the 6 for mega and 10 to the 9 for giga. And then tera. You don't have to know all these. That's like computer time right now. Also getting smaller, notice we are milli is 10 to the negative third, or a 1,000th of a gram, or a liter, or whatever it is. And then we go to micro with this funny little mu, Greek mu letter, but it's 10 to the negative 6. So again, it's 1,000 thousandths of this. And then nano, 10 to the negative 9, and pico, 10 to the negative 12. So some students like to look at it this way. Some students like to see the tens going up by the tens, and so sometimes it's helpful to like understand exactly how this metric system is organized. Okay, so this little area that I've boxed, I find the little saying of King Henry is the easiest way to know it. So King Henry died unusually drinking chocolate milk. So if you can remember that on a test, you can whip it right out for you and you can use it. So um, the K for king is the kilo, like a kilogram over here. The H is for hecto, which is a tenth of a kilo. The D is deca, which is a tenth of a hecto. Each, remember, divided by 10, divided by 10. The U is just the unit. So the unit can be the meter for length, the liter for volume, the gram for weight, the watt for energy, or the byte for computer memory. And then we get smaller by a tenth. So a tenth of the base unit is a deci. A hundredth is a centi, and a millionth, sorry, a thousandth is a milli. A milli thousand. Okay, mil thousand, right? Okay. So this box right here is kind of maybe an easy way to think or remember how this goes. All right, so this arrow down here is a big deal. If you are getting bigger, then you're going to divide by 10 each jump you do. And if you're getting smaller, you're going to multiply by 10. So for example, 1 meter is equal to 1,000 millimeters. But I could, if I didn't know that, let's say I don't know, 5 meters, I can look here and I can go, I'm going from meter to millimeter, and I'm going to jump 1, 2, 3 times, which means I'm going to take this decimal 1, 2, 3 times. Every time I do a jump, I stick a 0 in it, and that's how I can figure out moving back and forth on here. If this is hard for you to like multiply and divide, you can just do this jumping method. Nobody's going to judge you. I still do it that way too sometimes. So let's practice a few of these and see what you think. Okay, so this gives you all the little like conversion things. And this first one says 2.8 millimeters is how many meters. So I'm going to erase this so it's cleaner for you to see. All right, so I'm going to use my pencil color. All right, so I have millimeters, milli, and I want to have meters, my over here unit. So I'm going to go 1, 2, 3 this way. So 2.8 millimeters, I need to divide by 10. I should be getting smaller and smaller. Because remember, on a yardstick or a meter stick, 1 meter, there's all those tiny, tiny, tiny lines. It's 1,000 millimeters. So 2.8 millimeters, that should be a really tiny number because we're going the other direction. So we're going this way. So 2.8, and I need to move my decimal over 1, 2, 3 times. So I like to do it like this. I like to do it on my paper messy. 1, 2, 3. So I'm going to go 0.1, 2, 2, 8 goes there. So this decimal moved over 1, 2, 3 times, and I'm going to put a 0 in there every time there's a little divot there. So that's how that's the easy way to do it. You can do it in your calculator. You can take 2.8 divided by 1,000, and you would still get that. So whatever works for your brain, totally do it. Okay, I'm going to change colors just so we can like have some variety. Okay, so then the next one, 1.3 nanometers, and we're going to go to micrometers. This one's a little goofy. It's not on our normal one, so we have to look up here. Nano is 10 to the negative 9, and micro is 10 to the negative 6. So how much difference is there between negative 9 to negative 6? A space of 3. And are we getting bigger or are we getting smaller? So we're going from nano, which is 10 to the 9, to micro, which is 10 to the negative 6. So it's kind of like going from milliliters to meters. So it's the same thing. So we're going to divide by 1,000 or move it over 3 times. So 1.3, 1, 2, 3. So it should be 0.0013. 0.0013 micrometers. Okay, 300 milligrams. So if I have 300 milligrams over here, milli, and I want to go to gram, it's the same thing. So it's going to be 0.3 grams. I don't have to put the OOs. It's just going to go 1, 2, 3, move the decimal to here. Okay, 12 micrograms. Let's use this funky color. All right, so micrograms is this 10 to the negative 6, and we're going to nanograms. What is a nanogram? So now we're going the other way. We're going from a big thing to a smaller thing, so this number is going to get bigger. So 12 nanograms, there's a difference still of 3, so we're just going to multiply it by 1,000. So we're just going to go 1, so it's just going to be 12,000 nanograms. Okay, and then 250 milliliters. This is back to our good stuff here. Let's look at this one. So 250 milliliters. So I'm going milli, and I want to go to liters, which is the base unit right here, liters. So I'm going to go 1, 2, 3. So my decimals here, I'm just going to go 1, 2, 3. So it's just going to be 2.5 liters. All right, electricity, that's us, this unit. So we're going to do gigawatts to watts. Gigawatts are huge. Gigawatts are 10 to the 12th. And we're going to move all the way to watts, which is here the base unit. So that is a crazy amount of numbers. So we are going to Okay, so 400 gigawatts. If I was going to do scientific notation, which I feel like I would want to, 400 gigawatts is 4 times 10 to the 14, because a gigawatt is 12, but then I have these two zeros right here, so I have to put two more, so 14. And then how many watts is that? So to go to watts, I have, what is that ugly number? Oh, doggy, don't stop. 4 times 10 to the 14 is the gigawatts, and I want to know how many watts it is, and I have to multiply it by however many jumps I have to get to. This is insane. Oh wait, I think I'm telling you guys wrong. Hold on. I got out of control. Okay, 400 gigawatts to watts is going to be 4 times 10 to the 13. So 400 is 4 times 10 to the 2. And then I want to multiply it by its 11 jumps, right? 1 times 10 to the 11. So it's going to be 4 times 10 to the 13. Nice. Okay. That should be an 11. That's an 11, not a 17. Okay. Number 19 here. 5 times 10 to the 4 kilograms. So here's kilograms. And we want to go to megagrams, which is kind of crazy. I've never even heard of a megagram. This is silly now. Okay, so that's going to be just 3 jumps. This is 10 to the 3, and we're going to move to 10 to the 6. Is that right? So we need to divide it because that's getting to a bigger thing. So we're going to divide it by 1,000. And so it's just going to be 50 because this is 1, 2, 3, 4. Right? 1, 2, 3, 4. And we're going to divide it by 1,000. So I just take those 3 zeros away, and that leaves us with 50. Phew, that was horrible. There are tons of practice everywhere, online, everywhere, to do these scientific notations and to do these metric conversions. So if this is like, you're just like, it's okay. The important thing is you get to use your calculator, and you just need to memorize this King Henry thing, and it'll help you tons, I promise. So if this is like killing you, come after school and I'll go slower, or I'll try to do it a different way for you. Some brains really like this jumping thing, but some brains just really like to know, do I multiply or divide? And then you just kind of have to memorize these prefixes and know a milliliter is 1,000, a centi is 100, deci is 10, the base unit, deca's the other way 10, hecto's 100, and kilo's 1,000. So if that works for your brain, do it that way. As long as you get it right, it's okay. Okay, let's go to the next part. All right, the energy math. Whoa, that's so much fun. So you don't have to memorize any of these conversion things. The test will always give you what you need to know. And here's just a little helpful hint. On the APES test, the order that they give you these conversions is usually the order you need them on the questions. Very convenient. So that's helpful if you know that little trick. All right, so this first one is, let me scroll up a little bit, give us some space. Okay, So the city uses 10 billion BTUs, British thermal units is a kind of energy, right here, boop, right there. And every month they use it. So how many kilowatt hours is being used? So I like to take what they give me. So I'm going to write 10 billion, but I'm going to write 10 billion. Do I want to do it this way? No, I want to write 10. Why is my pen doing that? 10 times 10 to the 9. That's billion. Per month, right? BTUs per month. Okay. And then I know if I look around here, I want to have my answer in kilowatt hours. So do I see that anywhere? Yes, right here. 1 kilowatt hour is that many BTUs. So I can use that, and I'm doing dimensional analysis because it's way easier to set stuff up. Okay, so do 6 times, wait, I was jumping down. Okay, 10 billion BTUs, and I know that it is 3.4 times 10 to the 4 BTUs in a kilowatt hour. So my BTUs units cross out. This is like chemistry nightmare flashbacks. But here's why it's good. Because I know my answer needs to be kilowatt hours per month. And now I can look. What are my units that are left over? Kilowatt hours per month. So I know I set my numbers up correctly because it's giving me the right units. So I know that I am having this guy on top and this guy on the bottom. So that's a big deal to like check yourself to make sure you set up your problem correctly. And you get points for proper setup even if you mess up your math. Okay, so 10 billion. Let's do that. Cleared my calculator here. 10 second function e to the 9, which is weird because like really it should be 1 times 10 to the 10. I know you guys are calling me out on that, but if this is a 10, I did my scientific notation wrong, right? But that is 10 billion, or I could do 1 times 10 to the 10, same thing. Okay, whatever. Divided by 3.4 to the power of 4. And that gives me this really big, giant, crazy number. Okay. So I got 2. Whoa, I didn't get that. Boop. Okay. I got 2.94. I'm rounding to just 2 after this decimal. All those other numbers, it's okay. Times 10 to the 1, 2, 3, 4, 5. 10 to the 5. But I have to put my units or I don't get credit. So that's kilowatt hours per month. And then I have to box my answer so that College Board knows which answer is my final thing. Okay. That's crazy. Okay, so now, boop, boop, 21. If 1 barrel of crude oil gives us 6 million BTUs of energy, how many BTUs of energy will 1 liter of crude oil give us? Okay, so to do that one, I want to take my 6 million BTUs, which is 6 times 10 to the 6 BTUs per barrel. And then I know if I look up here, somewhere up here, right here, hold on, there are 42 gallons in a barrel. So I'm going to use that piece of information. So since my barrel is down here, I want my other barrel to be up here. It's gallons per barrel. So my 42 should go down here because it's gallons per barrel. And if I set it up that way, these barrels will cross out. But that's not what my answer is. I want to know how many liters. So now I need to know how I go from gallons to liters, which is right here. So now I know that there are 0.2 0.64 gallons per liter. So let's look if we set this up right. BTUs, oops, I want BTUs, ding dong. Boop, undo that. No, don't undo that, redo that. Okay, so here we go. I want my barrels to cross out. I want my gallons to cross out because I want my answers to be BTUs per liter. Do I have that? Yeah, BTUs per liter. So let's put that in our calculator. So I'm going to do 6. I'm running out of like light for my solar calculator. 6 times 10 to the 6 times 0.264 divided by 42 gallon thingies. So I should get 37714. 37714. Or I could put 3.77 times 10 to the 1, 2, 3, 4. Either one is okay in APES. So if you hate this scientific notation, you can just write it all out, but you're going to waste time and lose points. I'm just telling you right now. But fine, you make your own choice. Whatever you want to do. You're the boss. Okay, but oh, I screwed up because I'm not going to get credit. I forgot my units. No units, no points. So it's going to be BTUs per liter. BTUs per liter. Now box my answer. Okay, now look. Make sure you're reading the question and make sure your answer is answering in the unit that it wants you to have it in. Okay, so now there's this part 2. How many times do we miss the part 2 question? How many calories of energy will 1 gallon of crude oil provide? So how many calories of energy will a gallon of crude oil provide? Do you see anything with calories? We have this. I don't think we want joules, but we do have this. So we know that a BTU is equal to this many calories. Well, this is how many BTUs we have, so we can just multiply it. So we can take this answer and we can do 3.77 times 10 to the 4. Why? Why you are doing that to me? Times 10 to the 4, which is BTUs per liter, times 8.6 times 10 to the 5. 8.6 times 10 to the 5 calories per BTU. Hey, look what happens. Our BTUs cancel out and I have calories. I promise that says calories. See, it totally says it. Per BTU. So if I stick that in my calculator, times 8.6 times 10 to the 5. Holy cow, 3.24 times 10 to the 10. 3.24 times 10 to the 10 calories per liter. This is a 4. There. All right, that's 21. Wow, 21. Okay, let's keep going. You can push pause, but I can't, so here we go. 22. Okay, so we've got 150 pounds of CO2. It's released per million BTUs of energy. How much carbon dioxide is produced by each barrel of crude oil? And we are supposed to use information from this problem up here. Okay, so let's start with what we know. We have 150 pounds of carbon dioxide for every million BTUs of energy. So you can write out the whole 1 million if you want, or 1 times 10 to the 6 BTUs of energy. Okay, and then we also know, what do we want to know? How much CO2 is produced by each barrel? Okay. Okay. So so then we're going to take our answer over here. And we're going to go 3.77 times 10 to the 4 BTUs per liter. Why does the 4 never want to be looking like a 4? Okay, and then our BTUs cancel out, and that's going to give us carbon per barrel, because this is per barrel up here, of crude oil per liter. Okay, yeah, I think that's right. Yeah. Okay, so if I put that in my calculator, 150, oops, 150 divided by a million. Oh wait, I probably should do the timesy stuff first. 150 times 3.77 times 10 to the 4 divided by a million. And I should get, is it 0.56? Pounds of carbon dioxide per liter. Hold on a second. I'll be right back. No, I won't. I don't know how to do that. Okay, we'll just keep going. Hold on. Okay. Sorry, I had some like brain problems. Okay, 22. So I have 150 pounds. Whoops. I have 150 pounds of CO2 released, and I want to look up here at the old question of 21 that 1 barrel of crude oil makes 6 million BTUs of energy. So I know that 1 barrel of oil gives me 6 million BTUs of energy, and 150 pounds of CO2 is released for every 1 million BTUs of energy. So a barrel has 6 million. This makes 150 for every 1 million. So all I have to do is 150 times 6 to figure out how much CO2 is produced by each barrel of crude oil. So I do 150 times 6, and that is 900 pounds of carbon dioxide. Per, wait, CO2 per barrel. Okay. Woo, we did it. Okay. 23. A natural gas power plant is 60% efficient. That means for everything it burns, only for all the energy it's taking in, only 60% of it is converted to actual energy, which means 40% is waste heat. So you have this energy coming in to power something. 60% of it is going to actually go and make energy, but that also means minus 100, 40% of it is going to go out into the atmosphere and be waste heat. So, question. If 100 cubic meters of if 1 cubic meter of natural gas provides 1,000 BTUs of electricity, how much is waste heated? So all I need to know is 40% of 1,000. That's it. So 1,000 times 0.4 for 40%, which is 400. So it's 400 BTUs of waste heat. That's it. Done. That's a 5-second problem. Okay, the other thing we're going to talk about is fuel and efficiency for that kind of energy, so like gas and stuff. So let's go up here. How many gallons are in 15 liters of gasoline? You do not have to memorize that. Go back up here, find it. 1 liter is 0.264 gallons. Let's use that information. Start with what they give you. 15 liters, and we know that there are 0.264 gallons per liter. And so that equals, this cancels, 15 times 0.264 in your calculator gives you 3.96 gallons. So there are 3.96 gallons in 15 liters. That's the first part. Now it says, what would that cost in 1987 when gas was 89 cents a gallon? So I take 3.96 times 0.89 cents and put that in my calculator. It is $3.52. Very important you use the dollar sign. $3.52 per gallon. Remember, this is money, so you round for cents. So we wouldn't want to see like 3523 because that's not how we do money. And you must label this. This is for 1987. And then the other one says, what about when it's 2012 and it was 3.60 a gallon? And if you put that in your calculator, it becomes $14.26 per gallon, and that's 2012. What a difference in the gasoline prices. And now it's like 4 something, right? Okay, now your favorite thing. What's the percent change from 1987 to now? So your final minus your initial minus or divided by your initial. So the final is that 1426. Wait, percent change in gas prices. Sorry. So we want to do the per gallon thing. So we're going to go 360 minus 89 cents divided by 360. Put that in our little calculator. 3.6 minus 0.89. Wait, what did I do, Miss Ellie? It's initial. You're ding dong. Hold on. This should be 0.89. Silly, silly lady. At least I caught it. Okay, divided by 0.89. So it's 304. It's 304% increase. That's insane. Now, you could have used these numbers as well. Same ratio, and so you actually would have got the same answer. So either way is okay. Holy moly. Okay, so that is our mega marathon thing. If you have questions, let me know. Come to class, come get extra help, but this is what you're expected to know for this energy unit. So hopefully this was helpful.